question, we have to evaluate the definite integral x square minus x into dx from 1 to 4 as the limit of sums. Let's begin with the solution. And we have to evaluate this integral. Now, applying the definition of integral of the limit of sums. Here, the value of a is equal to 1 and b is equal to 4. So this implies that h is equal to 4 minus 1 upon n. So this is equal to 3 upon n. Now, the given integral x square minus x into dx from 1 to 4 can be written as integral of x square into dx from 1 to 4 minus integral of x into dx from 1 to 4. Let us denote this integral by I1 and the second integral by I2. First, let us solve the integral I1. The value of h is 3 upon n and f of x is equal to x square. So this implies f of a is equal to a square and a is 1, so f of 1 is equal to 1 square. Then we have f of a plus h, so this is given by a plus h whole square. So this implies that f of 1 plus h is equal to 1 plus h whole square, and so on up to f of a plus n minus 1 into h is given by a plus n minus 1 into h whole square. So this implies that f of 1 plus n minus 1 into h is given by 1 plus n minus 1 into h whole square, and the value of h is 3 upon n. So we have 1 plus 3 upon n whole square, and this becomes 1 plus n minus 1 into h, which is 3 upon n whole square. Now we have to evaluate integral of x square into dx from 1 to 4. So this is equal to b minus a, that is 3, into limit as n approaches to infinity 1 upon n. First we have f of a, that is f of 1, which is 1 square. Then f of 1 plus h, which is 1 plus 3 upon n whole square, plus so on up to the last term is 1 plus n minus 1 into 3 upon n whole square. So this is equal to 3 into limit as n approaches to infinity 1 upon n. First we have 1 square, from here also we will get 1 square, from here also we will get 1 square. So we have n times 1 square, plus then we have 3 upon n whole square, plus so on up to, from here we get n minus 1 into 3 upon n whole square, plus then we have 2 times of 3 upon n plus so on up to 2 times of n minus 1 into 3 upon n. So this is further equal to 3 times limit as n approaches to infinity 1 upon n plus from here taking 3 upon n whole square common, that is 9 upon n square common, we have 1 square, plus so on up to n minus 1 whole square, plus from here taking 6 upon n common, we have 1 plus so on up to n minus 1, and this is equal to 3 times limit as n approaches to infinity 1 upon n into n plus 9 upon n square. Now the sum of the square of first n minus 1 terms is given by n into n minus 1 into 2n minus 1 divided by 6 plus 6 upon n, and the sum of first n minus 1 term is given by n minus 1 into n minus of 1 plus 1 divided by 2, and this is equal to 3. Limit as n approaches to infinity 1 upon n, and taking n common, here we have 1 plus, taking n common, we have 9 upon 6 into 1 minus 1 upon n, taking 1 n with this and taking n with this bracket, we have 2 minus 1 upon n, and 1 n we have taken common, plus 6 upon 2 into n, from here we have taken common, so we have 1 minus 1 upon n. Now this is further equal to 3 times limit as n approaches to infinity of 1 plus 9 upon 6 gives 3 upon 2. So we have 3 upon 2 into limit as n approaches to infinity 1 minus 1 upon n into 2 minus 1 upon n, plus 3 times, since 2 3s are 6, limit as n approaches to infinity 1 minus 1 upon n. So this is equal to 3 into 1 plus 3 upon 2. Now here this term becomes 0 and this term becomes 0. So we have multiplied by 2 plus, since 1 into 2 is 2, 3 times. Now this term is 0. So we have 1 minus 0, 0. So into 3. So this is equal to 3 into 1 plus 3 plus 3, and this is equal to 3 plus 3 is 6, 6 plus 1 is 7, and 7 3s are 21. Therefore, the value of I1 is 21. Now let us consider the integral I2, which is integral of 1 to 4 x into dx. Here the function fx is x, so this implies that f of a, that is f of 1, is equal to 1. F of a plus h, that is 1 plus h, is equal to 1 plus h. F of a plus 2h, that is 1 plus 2h, is equal to 1 plus 2h, and so on up to f of a plus n minus 1 into h. So this is equal to 1 plus n minus 1 into h. Now h is equal to b minus a upon n, that is 4 minus 1 upon n, which is 3 upon n. So this can be written as 1 plus 3 upon n. This can be written as 1 plus 2 times of 3 upon n. And the last term can be written as 1 plus n minus 1 times of 3 upon n. Therefore, integral of x into dx from 1 to 4 is given by b minus a, that is 4 minus 1. 3. Limit as n approaches to infinity 1 upon n into f of 1 plus f of 1 plus h, which is 1 plus 3 upon n, plus f of 1 plus 2h, that is 1 plus 2 times of 3 upon n, plus so on up to 1 plus n minus 1 into 3 upon n. So this is equal to 3 times limit as n approaches to infinity 1 upon n. Now we have 1 n times, so 1 into n, plus taking 3 upon n common, we have 1 plus 2 plus so on up to n minus 1. and this is equal to 3. Limit as n approaches to infinity 1 upon n into n plus 3 upon n. Now sum of first n minus 1 terms is n minus 1 into n minus 1 plus 1 divided by 2. So this is equal to 3 into limit as n approaches to infinity 1 upon n into n, taking n common from the bracket. Here we have 1 plus 3 upon 2. Here this term becomes n, so this we have taken out. So we are left with n minus 1 upon n, and this is equal to 3. Limit as n approaches to infinity, this becomes 1. So we have, taking limit inside, 1 plus 3 upon 2 into limit as n approaches to infinity. Now we have 1 minus 1 upon n, and this is equal to 3 into, this term is independent of n, so we have 1 plus 3 upon 2, here 1 upon n becomes 0, so we have 1, and this is equal to 3 into 1 plus 3 upon 2 is 5 upon 2, so this is equal to 15 upon 2. Therefore, value of integral I2 is 15 upon 2. Now, the given integral is equal to I1 minus I2. Therefore, integral of x square minus x into dx from 1 to 4 is equal to I1 minus I2, and the value of integral I1 is 21 and the value of integral I2 is 15 upon 2. So this is equal to, taking 2 LCM, 42 minus 15, and this is equal to 27 upon 2. Therefore, integral of x square minus x into dx from 1 to 4 is equal to 27 upon 2. This completes the solution.